All right, we want to welcome everybody out today. Yes, for those of you that don't know me, I'm John Moyle with the University of Maryland, and with me today we have Megan Perdue, who's the county ag agent for, I can never pronounce this county right, Worcester County. We also have Jennifer Timmons from UMES. She's their poultry specialist down there. We are missing Jenny today. She says she hopes she's feeling under the weather, and so she's not with us, but she will be back with us next time. And we do have Georgie Cartanza, and she's the Delaware poultry specialist. So today we're actually going to talk a little bit about IPM and pest management. And with us today is Dr. Simon Zebelo. Anyway, he's going to talk to us today about some management strategies we have. Afterwards, we'll have some time for some questions and answers.
Again, thank you for the introduction. I am Simon Zebelo, an associate professor of entomology, working with insect pest management, mainly with agricultural pests. But I just try to put something about fly management in poultry houses for today. So today we will look mainly on arthropod pests of poultry operations. So when it comes arthropods, it includes all insect pests and spider mites. So flies, beetles, mites are often major concerns for commercial poultry operation in northeast US. So the confined housing system used in poultry creates a condition that favors growth and development of these arthropods. So the main insect pests that we will focus today is, of course, houseflies, little housefly and black garbage flies. But also there are pests in poultry house like darkling beetles, hide beetles, and also ticks and mites are very important pests of poultry production. However, today we'll focus mainly on houseflies, but we'll touch bases a little bit about other pests as well. So why are arthropods being pests? Why they are pests? When we call them a pest, we call them a pest when they start at discomfort or they start causing a discomfort to human being. Otherwise, they are not really a pest. When they start coming to our possessions, when they start transmitting disease, when they start causing discomfort for our property or for our animals, we call them pests. So why houseflies are pests? Houseflies are really abundant, or I can say it's number one pest in any farming, not only just poultry production, in the whole livestock production. Houseflies are very important pests. So fly population may create a public health nuisance around the farm and nearby communities. Houseflies can transmit more than 100 human and animal disease causing organisms. You can name like typhoid, dysentery, diarrhea, are different diseases that can be transmitted by houseflies. Even avian influenza can be transmitted by houseflies. It's obvious we know that they've been avian influenza transmitted by shoes, clothes, and equipments, but recently avian influenza pathogens found in adult houseflies. So houseflies are really important pests. So we need to look ways to manage them. Other pests are darkling beetles. These beetles cause structural damage to poultry house and create community problems at the time of house clean out. They escape from the house and they go to the nearby environment and they cause a lot of nuisances. And also they are a vector and a reservoir of many disease-causing pathogens like pathogens that cause Marcus disease, fowl pox, and other diseases. So they are really important pests. Another common pest in poultry houses, large northern fowl mites. Also, the fowl ticks are also important, but the mites are very important because they cause a lot of discomfort on the birds. They stress them out. Even they can cause anemia. They can suck a lot of blood and they can cause anemia. At times, they can cause also transient paralysis on birds. So they are important pests. But when we think about poultry house, also we need to think about beneficial insects. not only bad insects, also there are very important insects. There are mites, which are very good biological controls present naturally in any chicken house or poultry house. The manure attracts also these good insects. Mites, also hister beetles or clown beetles, they call them. The clown beetles also attracted to a kind of dry, not fresh manure, kind of dry or manure with 50% of moisture attracts these clown beetles. They are very aggressive predators. And also there are very important these tiny creatures or wasps. These wasps are biological control and they are parasite or parasitoid. They lay their eggs on the pupae of housefly puparium so that they can kill the new emerging flies. So when we think about bad insects, at the same time also we have to think about this good insects, because whenever we apply any chemical to control those bad insects, at the same time those chemicals also can kill these good bugs. And when we come with poultry housing versus pest problems, in caged layer poultry housing, we mainly see, we can see all of the insects, but we mainly see flies, these different types of flies, housefly, little housefly, black garbage flies. But in a broiler, we will see all of them in abundance. And in breeder houses, mainly we'll see mites, because they have close proximity between the birds. That's very good condition for mites. And again, mites, they suck a lot of blood and they cause anemia and paralysis on birds. Okay, but today I will focus mainly on these flies, housefly, little housefly, and black flies. And housefly, Musca domestica. Okay, suitable fly breeding conditions are present year-round in high-rise house because long-term manure accumulation and controlled temperature. If you want to control flies, just manage the manure. That's as easy as that. Always flies versus manure management go side by side. Okay, and then flies, they really love to say that's heaven for them, poultry houses, because they get very conducive environment or conducive temperature, and then they have manures. Wet manures are very good for flies to breed and raise their babies. Okay, so the effective housefly dispersal range appears to be from half a mile to 2 miles. They can fly within 2 miles radius, but there are reports they can fly up to 10 to 20 miles. It depends on the wind speed, wind direction, so they can disperse. Houseflies can transmit more than 100 human and animal disease causing organisms. Again, this is what I have mentioned. They can cause a lot of, they can transmit physically or mechanically. They are not going to take like mosquito or other insects. They carry them mechanically on their body. They carry bacteria, fungus, virus, whatever microorganism around the environment. They can carry them. Their body is really fit to adhere or to give a very good condition for the bacteria to attach or fungus or virus to attach. So they can transmit a lot of disease causing pathogens. So houseflies are very easy to identify. They are mostly dull gray in color with 4 black stripes on the back. You can see the red arrow there. You see these 4 black stripes in the thorax. So you can identify it very easily. And then they are really active. So houseflies breed in manure, spilled feeds, and moist, warm, decaying organic material. Each female can produce up to 6 batches of 75 to 200 eggs in 3 to 4 days. That means around 1,000 to 1,200 or 400 eggs during its lifetime. Laying the eggs in cracks, services under surface of their breeding material. So they like a place which is hidden from other animals, from other insects. from the predators. So this will lead us to the life cycle of houseflies. Houseflies, as we mentioned, they lay from 1,000 to 1,200 eggs during their lifetime. One female housefly lays from 1,000 to 1,400 eggs. And then the egg hatches within 12 to 24 hours. Very short turnaround. And then after the egg hatch turns to a larvae or maggot, first instar maggot, second instar maggot, and third instar maggot. It depends how many instars, how many larval stage. It depends on the temperature, availability of food. It takes from 4 to 7 days. Again, this one is associated with temperature. And then enters to the pupal stage. Within pupal stage, it stays 3 to 4 days and emerges as an adult. So the adult, to complete this life cycle, needs an appropriate or a conducive temperature. Temperature is very important to determine how long it will take. So the life cycle of flies highly dependent on temperature. For example, they need 10 days at 85 degree, 21 days at 70 degree, 45 days at 60 degree to complete this life cycle. And then adult flies live on average 3 to 4 weeks, but they can live twice these days. It depends on the temperature, availability of food. So most of the time, houseflies are active when the day temperature is between 80 to 90 degree, and inactive when the night temperature is less than 45 degree. So what will happen if the temperature is more than 90 degree? If it's really hot, their mobility is limited. They will lose the moisture from the body. Also, if the temperature is too high, that means the moisture in the manure will be low. That's not going to be conducive for their babies, also for themselves. As a result, if the temperature is too high, they will die. If the temperature is less than 45, especially if the temperature is less than 36 degrees, definitely flies dies. Whether it's larvae, egg, everything will die. Okay, so how they survive the winter? They survive inside the chicken house, inside the manure, because that's a very good conducive. We maintain the temperature for the birds. At the same time, we maintain the temperature also for the flies. So temperature is a key factor for survival of flies. So when you think about managing flies, it's better to think about what temperature. When there is no bird, it's better to think about lowering the temperature or just drying out, letting the ventilators run and dry the poultry house. So the other fly, which is really closely similar to housefly, is the little housefly. The little housefly resembles the housefly, but it's smaller and has 3 stripes on the thorax. And we have seen here the housefly has 4 stripes, but the little one has 3 stripes. Like the housefly, the little housefly may invade homes in nearby residential areas, but these little houseflies, they are not annoying. They are really calm. They stay around their food. If they land in one surface, they stay there longer. Even it's easy to hit them with water very easily than the housefly. The third one is black garbage fly. The black garbage fly is a little bit different in size, in color from housefly and the little housefly. Found in large numbers around poultry facilities, are shiny bronze black and are a little smaller than the houseflies. The life cycle is similar to that of the housefly and ranges in duration from 14 to 45 days. Unlike the housefly, the little housefly, black garbage flies tend to stay on their food source. They don't really fly away. Even at night, they stay around their food. But the little housefly and the housefly, they normally fly to the ceiling or the vegetation around. But this one is really calm, likes to stay around the food. A little bit lazy to fly. Black garbage fly larvae, which closely resembles housefly larvae, have been known to exterminate houseflies. The larva is a kind of omnivorous, carnivorous. Also, it eats also organic matter, and also it eats other larvae. So the black garbage fly larvae also eats housefly larvae. Sometimes it's beneficial, but not always, because its adults are also pests. But its larvae is relatively beneficial because it exterminates housefly larvae. So these are the three species of flies that commonly seen in our poultry house. Of course, there are horse flies or other blowflies, but it depends. These horsefly or other blowflies to come, they may need some dead animals or other organisms around. But these are commonly associated with manure, associated with wet condition in poultry houses. So what we need to do to manage flies, it is to introduce integrated pest management of flies. What is IPM? Or what's IPM of flies? An IPM is a philosophy that utilizes all suitable pest management tactics. But all the pest management tactics has to be socially accepted, economically affordable, and environmentally friendly. When you integrate, you have chemical, biological, cultural control methods, but when you integrate this, has to be in a way that's sustainable and environmentally friendly. So these tactics has to be used to keep the pest population below economically injurious level. Economically injurious level, what does it mean? How flies cause an injury or a damage to the production. First thing is, when you are producing birds, you have to have a very good relationship with the community, right? So flies, they can create a disagreement within communities, because if you have high population of flies in your houses, those flies can go to the nearby community. They can create discomfort. People start complaining, pursuing charges and stuff like that. That's kind of big damage that people need to think. Sometimes also flies, they can transmit disease within the folks, within the birds. There's other damage that causes. So economic injury level versus economic threshold level. These are two terms. Whenever you go discuss with pest management, these terms are common. So economic threshold level, a level at which the density of flies or the population of flies reaches that we need to take action, either by chemical or other means. But if the population passes the economic threshold level and reaches economic injury level, that means the damage is already happened. Even though we try to control the pest, our cost of production or our cost of control will be higher than the profit or the advantage that we can get by controlling the flies. So always the population of the flies has to be below economic threshold level. If the population reaches economic threshold level, we must apply a control measure. Mainly, if the population reaches and try to pass the economic threshold level, the only option we have is chemical control. We must use a very effective pesticide, which is registered in the state of Maryland or state of Delaware or Virginia, to keep the population below economic threshold level. But if the population passes and reaches economic injury level, the damage has already happened. The neighbors start complaining because the population is really higher. So after that, if you apply control measure, it still works, but the damage happens. So always better to keep the fly population below economic threshold level. So how do we know pest density to determine the economic threshold level? We need to use different methods in order to quantify the density of flies, in order to maintain the population below economic threshold level or action threshold level. There are different methods to be used. Some people, they use visual, but sometimes visual analysis may be misleading. So you have to use a standard quantitative methods to analyze. For example, you can use baited jug trap. You can put some attractants in the jug or this gallon milk jugs, and then hang around the poultry houses. And if you count 250 flies per week per jug, that could be economic threshold level. So that will tell you, hey, go ahead, apply chemicals or use cultural method, either cleaning house, or if there is any wet, or if there is any source of water that makes a wet condition. So you have to rely on that number. Also, you can use sticky traps or yellow sticky cards. So if you see 100 flies per sticky card per week, that's again a threshold. You can have just not only one sticky trap, you can have several sticky traps in a house, and then take the average. If the average is 100 flies per sticky trap, or that's the line, the action threshold. So that means you have to spray or you have to take action before the flies start flying away and reaching to the community. So the economic injurious level, whenever you determine an IPM program monitors pests and conditionally tracks population trends over a period of time. Once you clean the poultry house, you have to have first some traps, either jug trap or peg or sticky traps. Okay, so these sticky traps are very good. The insects are not attracted because you add any attractants. They just wonder they will come to the yellow color or white color. They just either they leave or they get stick there or leave some pegs. So you can count those two. So to successfully monitor depends on three. To successfully monitor depends on where in the barn or monitoring cards are hung or placed. Preferred locations are those where flies tend to congregate. This usually any calm area along walls, below air inlets or baffles, or near posts. The end of the barn where the feed hoppers are located is often preferred location for flies gather. And avoid placing cards near climatic disturbances like drafts and heat sources. Anything that has very active or blowing air has to be avoided, because that's not an ideal place where you put the cards, because these cards are kind of screen where you monitor the number of insects visiting your farm. So normally the threshold is an average 100 flies per card, but this threshold can go lower or higher. It depends. It depends on many factors. For example, proximity to neighbors. You can go 50, you can go 40 flies per card. It depends how far is your farm from the community. Okay? Also, potential transmission of a disease. If there is any disease, if there are some animals are dying, those pathogens can be transmitted by flies. So your threshold could be lowered as low as to 2 to 3. You don't need even to see any flies. Okay, time of the year or cycle of the birds. That will determine how many flies. That 100 flies per card is kind of general standard, but it depends. It can be changed because of proximity to neighbors, cycle of the birds, and potential transmission of disease, and cost of pesticides. Okay, so this is one example that collected from poultry houses, week 1 through to week 15. So you can see the number increases gradually. So when it reaches 100 flies per card, that's a threshold level to apply any control measurements, mainly chemical controls. So, okay, now you have your card around 100. What you need to do in order to maintain the population of insects below economic threshold level. The insects has to be under this action threshold level. If the population reaches here, you must apply chemical control. As you can see, in order to maintain the population under economic threshold level, the first thing you need to use is cultural method of control, manure management, moisture control, sanitation. This is the base, all control measures. If this is kind of part of the planning to maintain the population below economic threshold level. And the second alternative is biological control. You can introduce some parasites, some beetles to the poultry house to maintain the population below economic threshold level. But if the population passes economic threshold level before it gets economic injury level, the best option or the last resort is pesticides. Pesticides are really quick in action, cost effective. They can help you to reduce the population very quickly. So let's see these different control methods one by one, starting with cultural control. Fly control is basically manure management strategy. If you control the manure, you can control the fly very easily. Dry manure, 50% moisture or less, reduce the stability for fly oviposition and suitability for fly oviposition and larval development. Not only that, dry manure is also good for the good insects. For the biological controls, they like a dry manure. For example, the wasps, the beetles, they need to get a little bit composted manure. They don't really like fresh manures. So 50% moisture or less reduces suitability for fly oviposition and larval development. Also, it provides desirable habitat for beneficial parasitoids and predators. Fresh poultry manure has 75 to 80% moisture, and flies can breed in 50 to 85% moisture. They like that moisture. If it's dry, like I mentioned before, if the temperature is really high, it dries also the manure. As a result, that the fly cannot survive. Okay? So, moisture levels are affected. Moisture levels in poultry house are affected by leaking waters, condensation from non-insulated overhead water lines, improper ventilation, seepage from an exterior water source could be a good source of moisture, which aggravates or which enhances the production of condition. Okay? During spring and summer, when fly and beetle dispersal is major concern, manure that must be removed from the building can be piled and tarped to kill the developing pests. So if you tarp the manure outside, it generates very high temperature. It's kind of composting them. That kills a lot of the larvae or maggots inside the piled manures. That's the other method to control the fly population. So this is cultural or physical control method. The other method is biological control method using beneficial insects. For example, here in the video, I don't know if you can see it clearly here, there are mites. This is the larvae of housefly. These are mites. They are feasting on this larvae. So these mites are really very active and then aggressive. So in order is this micro-hilled mites is the major predators in caged layer operation. And mites feeds on housefly eggs and first instar larvae. It can consume up to 20 housefly eggs per day. That's a lot. Just one mite can consume 20 housefly eggs per day. For any appreciable impact by mites, large mite population are required, and then this mite population or other predators can be purchased and introduced to a poultry house. About 3 to 4 weeks manure accumulation are necessary for mite to become established. They don't really like fresh manure, which has higher moisture, just like they need around 50% moisture on the manure to survive. Another aggressive biological control is the principal hister beetles or clown beetles. Small black beetles, approximately 1/8 of an inch long. Both adults and larvae feed on housefly eggs and first instar larvae, first immature or the first tiny maggots. And also, like mites, these beetles also, they like a little bit composted, a little bit old manures. They don't really like the fresh manure to survive. Another hister beetles is also present in lower number on poultry farms in the Northeast. So these are two types of beetles. I don't know if you can see clearly, but I can share this slide so that you can have the pictures clearly in your computer or on cell phone to identify these beetles. And what I want to say is these beetles and mites, they are naturally present in your farm, but not at high population to control the pest. So they will need an enhancement, an introduction or augmentative release periodically. When the winter comes, their population significantly reduces. Okay, I will provide a link for where you can get some of these parasitoids and predators. Another biological control is these tiny parasitoids. These are wasps. They are very, really minute. Sometimes it's very difficult to see them, but they are really effective control for houseflies. Parasites are extremely noticed because they are extremely small, as you can see, between 1/6 of an inch to 1/8 of an inch. Occur naturally in low numbers on many farms. They live in manure or other decaying organic matter and search for fly pupae. What they do is, this is fly pupae. They lay their eggs. The egg hatches inside the pupae and enjoy the internal body matter of the fly. And then when they reach to adult, they will go out of this pupal. Okay? They live in manure or adult female parasitoids lay an egg on fly pupae within a puparium. Because of naturally low parasitism levels, control programs are sometimes based on mass release of commercially rare parasitoids. These are different websites where you can get these parasitoids. You can get from IPM laboratories in New York, Planet Natural, Grow Organics, Arbico Organics. They provide the pupae of these parasitoids. So they are really effective. And chemical control, as I have mentioned, chemical control is the last resort, the last option when the population try to reach above economic threshold level. Use them when you are only forced to use them. Chemicals are really good. They are fast in action. Only matters for insects approaching economic threshold level. That's the only option. You cannot use biological control. You cannot use cultural control. If the insect population is really high, you must use chemicals, but make sure those chemicals are registered to use in poultry farm. And then the other good thing about chemicals, you can get different mode of action. There are dusts, liquid sprays. You have different mode of action. They are readily available. They are cost effective. You apply and then you can control the flies very easily. So obviously chemical has a lot of advantages, but they have also disadvantages to use them. Toxicity to non-target organisms. These chemicals that you use to kill the flies also can kill the biological controls, non-target organisms. Also, those pesticides can be washed, enriched to water body, and then can kill fishes still, other aquatic organisms. Okay, and also residual effects. Some parts of pesticide remain on plant parts, or it has to be on animal parts. Somehow they can reach to internal part of the animal. So the other residual effect, they pollute the ecosystem, resistance. This is very important. Whenever you use chemicals, try to use different types of chemicals, not just one type. Flies are really good on developing resistance. Because of their short life cycle, they can recruit a new gene that helps them overcome some pesticides. So always have a variety of pesticides to use with different active ingredients. That's another option. Resurgence rising again into life or activity because of resistance. When you spray them continuously with the same type of active ingredient, you kill the natural enemies. But the flies are really fast to develop resistance, and they can come back because the pesticide that we apply kills the good insects. The good insects, normally they maintain the population. If not because of the good insects or the beneficial insects, the world would have been full of pests. So whenever we apply pesticides, it's better to think about this good animals because of this resurgence. For time being, we can't really kill the target pest, but for a long run, the target pest might come in high population. This is one. The other reason is maybe the target pest can be controlled with chemicals, but another secondary pest which was really secondary, it can come as a primary pest because those natural enemy being killed by the chemical. So this is the disadvantage of chemicals. Other information I want to share about chemicals is whenever you try to use chemicals, just to be in safe side. Here in Maryland, in the Maryland Department of Agriculture, there is a website, a very good database. You can confirm very easily. You can go online, go here and put housefly, and then it will give you what type of housefly, what type of pesticides can be used for housefly in poultry houses. There is a very detailed information on that website. Even the the trade name of the pesticides, whether you can use them or not, because it's very important. I always read the product labels carefully before applying any pesticide mix and apply as desired. Do not overdose, do not treat too often, follow all precautions exactly, and a reminder that improper practice can lead illegal residues. Even when proper materials are used, it is illegal to use pesticide in any manner inconsistent with the labels. So that's why always it's better to go and look for the information in this website so that you will be covered whatever pesticide you use in your poultry house. So just to summarize what I have discussed about pest management, normally is first step about IPM in fly management is planning, help operators understand the extent of their insect problems, and also chart a course, address issue proactively instead of being reactive. You need to have that graph. You need to know the action threshold level as part of your planning. And also you need to have chemicals, variety of chemicals to use ahead of time. And implementation is the second step. Implement insect control tactics to reduce infestation. Execute an integrated pest management approach to control the insects. Integrated chemicals with biological, with cultural. One alone may not work properly. It's better to integrate one another. Start with cultural, cleaning, sanitation, manure management, and go ahead, introduce biological controls. And as a last resort, chemicals are really fast and helps to reduce the fly population. And third step is very important always, evaluation, follow up on program effectiveness, checking and monitoring on a regular basis, reviewing, adapting our program as needed. Sometimes you need to have a threshold, 100 flies per card. Oh, you can decide this is too little or too much. You can go 50. It depends. How far is your farm, your poultry house from the community? Is there any complaint? Because the relationship with the community has to be really smooth. So it depends on how you formulate. So you have to evaluate the method that you are using, the pest control. Having said that, I would be happy to answer any question. This program was sponsored by USDA and NIFA. And if you want to read more about this, most of the information I got from this Philip et al. It's a nice article. I recommend if you have time to read in detail whatever I just presented, I got from that.
Thank you very much. Hearing none, I want to thank you all for coming out and joining us today. We look forward to seeing you at our next meeting. Thanks, guys. Thank you.
Yep.